Imagine it's a hot afternoon in ancient Babylon, nearly 4,000 years ago. Mud brick ziggurats rise into the sky, merchants haggle in bustling markets, and scribes sit at wooden desks hunched over small slabs of clay. These scribes aren't writing letters or inventories, though. They're inscribing numbers, shapes, and equations, creating what are now some of the oldest known records of advanced mathematics in human history. These are the Babylonian mathematical tablets, artifacts from a civilization that flourished in Mesopotamia between 2000 and 1600 BCE. They're small, unassuming chunks of clay, scratched with wedge-shaped cuneiform symbols. But don't let their modest appearance fool you. These ancient tablets reveal a mathematical sophistication that would astonish even the most seasoned scholars when they were rediscovered thousands of years later. So, what exactly were these tablets, and why should we care about them now? Well, to begin with, they remind us that mathematics is a universal language with ancient roots. They show us that long before the Greeks formalized geometry or Isaac Newton invented calculus, the Babylonians were solving equations, calculating areas, and dealing with numbers in ways that laid the groundwork for the mathematics we depend on today. Let's start with the basics. Babylonian mathematics was written using a base 60 or sexagesimal number system. That might sound strange to those of us who count in base 10, but you're more familiar with base 60 math than you might think. Every time you check the time, 60 seconds in a minute, 60 minutes in an hour, or measure an angle in degrees, you're using a system inherited in part from Babylonian innovation. Now, what did they do with this system of numbers? Quite a lot, actually. The Babylonians used their tablets for a mix of practical and theoretical purposes. On the practical side, they made calculations for farming, construction, and trade. Imagine you're a Babylonian farmer needing to figure out how much grain to trade for livestock, or a builder calculating the volume of bricks you'll need for a temple. The tablets held the mathematical recipes for solving these kinds of problems. But beyond practical arithmetic, Babylonian mathematics ranged into territory we might describe as proto-algebra or even pure geometry. One of the most famous examples of this is a tablet known as Plimpton 322, a clay slab around 12 centimeters long that dates back to roughly 1800 BCE. Plimpton 322 isn't just any mathematical record. It contains a list of Pythagorean triples, the sets of numbers that satisfy the famous equation a squared plus b equals c squared for right triangles. What's particularly astounding is that the Babylonians worked with these relationships over 1,000 years before Pythagoras was even born. This level of mathematical abstraction reveals a culture that didn't just use math as a tool, but saw it as a subject worth exploring in its own right. Another intriguing tablet, often called the Babylonian tablet YBC 7289, demonstrates an approximation of the square root of 2, accurate to several decimal places. Think about that for a second. While most of the world was still using math for hunting or bartering, the Babylonians were calculating square roots with mind-boggling precision. What drove them to pursue this? Certainly some of it was necessity. Their advanced bureaucracy required precise record-keeping. Their architecture demanded complex geometric calculations. And projects like land division or flood management pushed them to refine their mathematical tools. But the presence of purely theoretical work suggests something deeper, a recognition of the beauty and power of numbers. The methods reflected on the tablets also give us a fascinating glimpse into how they thought about math. For example, instead of using written equations like we do today, Babylonian math often relied on visual and procedural methods. Tablets described problems step by step, sometimes accompanied by simple diagrams. Their approach was methodical and incredibly versatile, allowing them to solve quadratic equations, measure irregular shapes, and even dabble in concepts that we'd now associate with calculus. And here's the cool part. Despite the vast gap in time and culture, we can still recognize what they were doing. Their problem-solving strategies resonate because they're the same kinds of patterns and relationships we still study in schools. It's humbling to realize that when you solve a geometry problem or balance an equation, you're following footsteps that stretch all the way back to these ancient scribes pressing cuneiform into wet clay. Of course, Babylonian math wasn't perfect. Their number system, while brilliant, lacked a true zero. a concept that wouldn't emerge until centuries later in India. This could make their notation ambiguous, and figuring out exactly what certain tablets mean often requires careful interpretation by modern historians. But even with those limitations, their contributions were extraordinary. So why does this matter today? What can we, in our age of computers and quantum physics, possibly learn from a few old clay tablets? First, they remind us that the pursuit of mathematical knowledge is a deeply human endeavor. The Babylonians lived in a world without the conveniences we take for granted. No calculators, no graph paper, no internet. Yet their curiosity about numbers led them to discoveries still relevant millennia later. Second, these tablets highlight the importance of math literacy as a foundation for civilization. The Babylonians may have used their skills to trade and build, but as their example shows, mathematical innovation builds on itself over time. The leaps they made in arithmetic and geometry didn't just stay in Babylon. They spread and influenced cultures across the ancient world, becoming stepping stones for the Greek mathematicians, the Islamic scholars of the Middle Ages, and eventually the scientific revolution. Today, as we tackle everything from climate change to space exploration, mathematics remains as critical as ever. Sure, we've built on Babylonian ideas to create things they could never have imagined, but their legacy reminds us where it all started, and how essential it is that we keep nurturing the same intellectual curiosity that once flourished along the banks of the Euphrates. So the next time you see a triangle and think of Pythagoras, or divide quantities and double-check your time in seconds, take a moment to remember the Babylonians. Their clay tablets may look old and cracked, but their numbers and ideas are timeless, a testament to the enduring power of math to shape the world.